A national team of scientists has descended on the Porte airport with an important mission to find out if air pollution is making our weather worse. Kim Castro shows us how analyzing tiny particles of soot, smoke, dust, and other aerosols keeps us all weather smart.
The Porte Airport has become base camp for studying the air around us and the sky above us. The goal, to find out, are aerosols helping to fuel our strong southeast Texas storms? With an endless supply of heat and humidity pouring in, we see our bubbling Texas clouds grow quickly. What we don't see, what's inside them, tiny aerosol particles.
We need those particles for the water to condense onto to form clouds.
And not all particles are created equal. Some reflect light, some absorb it, some help water droplet condensation, and others help with ice crystal formation.
Based on their composition and the size and the numbers, it changes how the particles can act as cloud condensation nuclei, which then impacts how precipitation forms.
In a thunderstorm, ice crystal formation and collision is what charges the storm and makes it electrified.
When you have more aerosol particles, you get lots of smaller cloud droplets rather than a few big ones. And what that means is in the updraft that forms a cloud, it's hard to get those particles to collide.
And so the question is, how much of a storm's intensity is driven by that as opposed to the weather systems moving in?
So you have a cold front comes through and that really lifts things up, makes storms happen. In that case, I think you add a few aerosols to that, it's not going to have a huge change because you're already so strongly forced.
But Jensen says on days when we don't have fronts and do have aerosols, they likely influence our storms. Now the question is, by how much? More than 60 measuring tools have been set up at the Porte Airport to track just that. This year-long project that started this past September records data from radars, light beams, weather stations, and weather balloons to look at cloud composition, air makeup, wind intensity, and many more atmospheric conditions. The objective is twofold: improve weather forecasting and
help policymakers understand if changes need to be made, how can they be more surgical and have some more targeted impacts.
Another added benefit, this data is recorded and available in real time, and anybody can access it. Air quality researchers like U of H Associate Professor James Flynn are taking advantage of that.
There's so much information here. One thing that we'll be using here, for instance, is the solar radiation measurements that are being made, as well as vertical profiles of wind through different instruments.
That air quality information is collected in this aerosol observing system. The stack right there collects an air sample which gets sucked into this container where 30 different instruments process it. The data collection will continue through the end of September, but researchers say they'll continue to observe that data for years to come, potentially a decade. That's how long they say it's going to take to understand how aerosols are impacting us. In Porte, for KHOU, I'm meteorologist Kim Castro.
Ongoing science.
Yeah.
That's why we have years and
Fascinating
decades
stuff.
of it.
Yeah, we got to dig in and find out what's going on up there.
Absolutely.